Welcome in the third session. All participants, are you ready? Okay. Now, the third session will be delivered by Engineer Bipul Kumar Shahi. So let me introduce Bipul Kumar Shahi. Engineer Bipul Kumar Shahi, he did his BTech from Uttar Pradesh Technical University. He also completed his MTech in Embedded System from Uttar Pradesh Technical University. He is a senior artificial intelligence and blockchain consultant, AI Council. He has experience in the field of IoT, blockchain, artificial intelligence, and Android app development. He has delivered workshops and trainings in more than 150 institutes and colleges and the universities on technologies, namely embedded system, IoT, AI, ML, Android, and drones. He has also given the corporate training and FDP in the field of IoT, blockchain, artificial intelligence, data science, machine learning, and deep learning, and neural network. So this is a brief introduction about the Bipul Kumar Shahi. Now, I humbly request Bipul Kumar Shahi to start the session. Please welcome, sir.
Okay, thanks a lot, everyone. Excuse me. Hi, everyone. Very good afternoon. I am Bipul. I will be with you for delivering this session over machine learning. As far as today's topic is concerned, today we are going to discuss about supervised learning part. Okay, and in the supervised learning, we will discuss the classification kind of things, like how we can classify or how a machine generally classified between different objects or different kinds of categories, right? So we'll start from very scratch, okay, and I will try to explain in a very layman kind of a term, and we'll use very easy terms so that it can be easy for easy to understand for everyone, right? Still, if you are having any doubts or anything that you couldn't understood, I will give you a time. I will give you a window where you can just ask your query, and I will try my best to answer your questions, right? So let's start my share my screen. I hope my screen is visible to all of you, isn't it? Yeah?
Yes, sir, it is visible.
Okay, that's great. So what we have to discuss as far as topic is concerned, we have to discuss something that is known as supervised learning. Okay, supervised learning, correct? Now question is, what is supervised learning? That we need to understand first. Okay, so a story don't starts with supervised learning. The thing that is having all these kind of stuffs like supervised and supervised reinforcement, okay, is known as what? Machine learning, right? So machine learning is something that is having all these kind of steps, right? So I hope you must have some basic idea of machine learning. Okay, it is just a process to make a machine learn, to make a machine independent so that it can do its task on its own, okay, without human intervention. Okay, and how a machine will get learned? Obviously a machine will get learned with the help of some kind of you can say learning algorithms, okay, or some learning paths, okay, with the help of some past data. Okay, the same process through which we learn with the help of our experiences. The same thing will be applied over the machine. Machine will also learn with the help of experiences, right? Who will give experiences to the machine, and how a machine will earn experiences? Machine will earn experiences with the help of past data, okay, the data that is given to its before the implementation. Okay, that means all those things that happened in a particular domain. Suppose I have to make a machine model, okay, or I have to make a ML model to predict weather. Okay, I have to make a machine learning model to predict what? To predict, suppose, weather. Okay, so weather is what? Weather can be like a number of things I can predict in the weathers, right? Like what can be like environment today? It is going to be cloudy environment, right? It can be kind of a rainy environment, it can be sunny environment, right? So that's what we can predict. We can predict the temperature, what can be the temperature range that is going to be today, okay, or for next day. So in that case, if a machine will predict this thing, the environmental situations or environmental figure, okay, so how it will predict, how it will define, how a machine will tell you that what can be the weather. Machine will have all past data, okay, the data before today, okay, like whatever data that is all that is representing all those things that are already happened, isn't it? So if machine will have all the past data, and with the help of data plus some mathematical algorithm, okay, a machine can generalize this particular thing, okay, to extract the information from it, okay, to extract the relevant information, I should say, okay, to extract the relevant information, okay, to extract the relevant information, so that on the basis of that relevant information, the condition, or the current environmental situations can be predicted, or upcoming environmental situations can be predicted, isn't it? So based upon that, machine will predict. For example, suppose it is winter season, right? So we can easily predict, okay, it's a winter season, that's why I have to wear a kind of a sweater or something like that, isn't it? If it's summer season, I have to wear some kind of thing, some kind of a, clothes that is preferred in summer season, isn't it? So it's like, if it's January, then we can easily say, okay, in January it is going to be winter season for people like in Delhi and all, right? So how can I say that, okay, that in the month of January it is going to be winter season? Because since my birth, I all the data that is there in my brain, okay, that data is saying that each year in the month of January there is a winter season. So there is an algorithm working in my brain, okay, that algorithm is counting the month, okay, and on the basis of month it is saying that if it is January it will be winter season, if it is December it will be winter season, if it is July it will be winter season, right? The same way machine will extract the relevant information, and based upon the information it will just define some reference point, and based upon that reference point machine will give the predictions, okay. So that is how machine works, or that is what a machine learning concept. I hope many of you are clear with it. I am just trying to give you a quick refresh, okay. Now, with the machine learning, there are so many subtypes. One of them is supervised. Okay. Another is unsupervised. Then we are having a reinforcement. Okay. With the supervised, what happened? A machine learns with the help of two entities. Okay. A machine learns with the help of two entities. What are those two entities? One is called feature. Okay. And second is called label. Okay, that means if I will write, I suppose I have a student, okay, and he is in class 1 or class 2. I have to teach him, okay, I have to teach him about the multiplication of the tables, right? In that case I will start teaching him like this: 2 cross 2 is equal to 4, 2 cross 3 is equal to 6, okay, 2 cross 4 is equal to 8. In this case, what are these are basically our features, isn't it? These are features and these are our labels. Okay, that means if a person who is knowing nothing, if a machine who is knowing nothing, if there is something I have to train who is knowing nothing, in that case I have to train them in both aspect. Okay, I have to give the features and the effect of that feature. Okay, for example, in case of weather forecasting system, okay, what we need to do, we have to give feature. What can be the feature? Like temperature, humidity, moisture, okay, speed of air, these can be features. Okay, and label, like on a particular day, if suppose there is a x temperature, y humidity, z moisture, k air speed, right? Based upon it, sorry, based upon, suppose there is a x temperature, y humidity, z moisture, k is your air speed. Based upon it, suppose the weather is cloudy, okay, so there is some other day, okay, it is day 1, x1 y1 z1 k1. Some other day, x2 y2 z2, okay, k2, okay, it is something called rainy. Okay, so in this case, cloudy is what? Cloudy, rainy, these are labels, and these are what? Features representing temperature, humidity, moisture, and speed of air speed, right? So same way, if I collect n number of data, okay, and thereafter I want to train a model so that that model can predict in the case where there is your temperature, x question mark, y question mark, z question mark, z is what? Moisture, and k question mark, okay, then question mark. That means what will be the weather condition, okay, this is what we have to predict. Please check your mic, or like all of you should be should be muted, right? Thank you. Okay, so this is what we have to predict, or not we have to predict, actually machine needs to predict. Okay, so what machine will do, if machine is using this particular data which is having two different entity, feature as well as label, okay, that machine is getting trained through a process known as supervised learning. Why supervised learning? Because someone is supervising it, correct? If during the course of learning, okay, during the course of learning, if machine will do it go in a kind of wrong direction, if machine get trained some wrong, you can say, is predicting some wrong entity, okay, in that case someone will supervise and will tell the machine that, okay, no, you are going in a wrong direction, you are on a wrong path, please correct your direction, please correct your path and make the predictions correct. Okay, so who can supervise? The person who is knowing the answers, the person who is knowing the actual happening, actual things, okay, they can only supervise. That means I can train a person on this particular thing if I'm knowing this entity. If I'm not knowing two, what is 2 cross 2, then I can't train, I can't supervise anyone, right? So suppose I have to kind of give some like there's a person, there's an examinee, I am an examiner, I have to check a copy, I have to check a kind of answer sheet. So if I have to check an answer sheet, in that case, how can I check answer sheet? If I am knowing the answer, then only I can check answer sheet. If I will check the answer sheet, I am knowing the answer, then I will give a grade. Okay, so that grade will help the examinee to understand, to get the information about how much learning he did actually having, how much knowledge he is having. Okay, because his grade is telling him that, okay, you are having this much knowledge, you need to work a little harder or whatever, like that. So 80%, 70%, like that, right? So actually a person has written, and thereafter I checked the answer sheet, I had given the grade. That means what I did, I supervised his learning process. Same thing happened over here. A machine get trained with the help of data. Then what we do after the training, we ask the machine that, okay, you got trained. Now just let me know what will be the condition if x2, y2, z2, and k2 is the environment, is the environmental situation. Will it be rainy, cloudy? So suppose using this thing, okay, machine told it is going to be sunny. So what I do, I will tell machine, no, just now I trained you and I told you this is going to represent sunny. Sorry, this is going to represent rainy. Then how can you say it is going to be sunny? Okay, getting a point. That means first I will tell the machine, okay, like x2, y2, z2, k2 is representing rainy season, or you can say rainy day. Okay, then I'm asking a machine that just tell me x2, y2, z2, k2 is representing what? Machine told, the algorithm told that it is sunny. So what I do, I just tell him that, no, you are predicting wrong. Okay, you have to make your learning more concrete, just take more data from me, or I will change the algorithm, I will change the process, I will do some kind of manipulation to make it possible that machine can predict the correct entity. Okay, that's why it is known as supervised, because I am supervising it, right? In unsupervised, these labels are not there. We use only features to train our machine, but unsupervised is a topic that will be discussed later on. That is a separate topic that will be discussed in very much detail. So I'll come to that part, but today we are going to discuss mostly about the supervised. Okay, so in the supervised, again, the categories are divided. Okay, there are two categories in supervised, right? One is known as your just a minute. Okay, one is known as your classification, okay, that we will discuss today, and second is known as regression, that we will discuss tomorrow. Okay, classification and regression, these are two things that are there, isn't it? So if anything that you're knowing and anything like kind of you are not having any, you are having any doubt, just do make a notes of that. I will give you time, and during that time you can ask your queries, isn't it? So classification and regression, these two things are there. Okay, there are two types of machine learning. One is classification, second is called regression. Okay, what happens in classification? Here the predictions will be on category wise. That means categorical prediction. Categorical prediction means what? The example just now I took, okay, just some moments back, I took an example that environmental condition can be sunny, it can be rainy, okay, it can be cloudy, okay, like this. So these are what that means. I my machine can predict out of these three, one category it will predict each time. That means number of categories are fixed. Okay, it is not kind of an infinite number of categories are there. They are fixed. Only out of three and one situations will be predicted. Correct. So it is a categorical prediction or the classification based prediction. Okay. Next, consider a case where we have to make a prediction of sales value. Okay, so sales value you can't you can't kind of inbox, or you can't limit the values of sales. You can't say that only sales value can be $5 or $2. Okay, you can't say that a sales value can be 10 lakh or 20 lakh. Okay, that is only two sales values are possible, either 10 lakh or either 20 lakh. Okay, no 15 lakh, no 5 lakh, it is not possible, right? Sales value can be anything. It can be 0, it can be 10, it can be 15.5, it can be 16.2, it can be 100, it can be 500. Okay, that means there is no limit over here. You can't define any range over here that okay, there are only three possible sales values are there. Okay, profit or loss is fixed, either profit or either loss, but fixed number of sales value is not there, right? So it is what? It is continuous prediction. It can be anything. Okay, it can be anything. Any sales value can be there from 0 to infinite, right? In some cases we may, like in some cases we may require, like the predictions can be negative also, negative infinity to positive infinity, like temperature can be negative or positive, anything, isn't it? So over here, the case where we have to predict continuously, or machine needs to predict a value in a continuous range. Okay, there the kind of approach that we have to apply is known as regression. That means through regression approach we used to apply, we used to through regression approach we used to train our model and do the different kinds of stuffs. Okay, so we will discuss regression in detail, but today it's the day of classification, so we will move forward with classification approaches. Okay, so for classification, there are a number of algorithms are there. Okay, to train a model, okay, we use certain number of algorithms. We will discuss some algorithm. Okay, like suppose I have to train a model on the basis of classification. Okay, that means I have to train a model to predict something or in a some categorized format. Okay, suppose I have to predict kind of what I should say, anything I can consider. It can be like what I should say. It's like suppose sign language, but sign languages have more than too many identities are there. Uh, it can be kind of a flowers. Okay, or better, let me take consider fruits. Okay, fruits. Okay, let me consider fruits. Okay, so I am having what I suppose I am having two types of fruits. Okay, it can be like kind of apple. Okay, and B I'm having suppose mango. Okay, I'm having two types of fruit over here. Okay, and what I want that my machine should identify them and should predict and should tell me that okay, these are apple and these are mango. Okay, these are apples and these are mangoes. Okay, so how a machine will identify and will tell me that okay, these are apples and these are mango? Machine will use some algorithms in the backend. Okay, what are those algorithms? Let me tell you. For example, apple. Okay, there will be some features defining the apple, and there will be some features defining the mango. That is a vector. It is a vector that is representing the features of apple, and this is a vector b representing the vector b representing the features of mango. So what can be the features? It can be anything. It can be like, for example, we can use the size, okay, or we can use the colors value as well. Okay, like RGB, red, green, blue color, and all the combination of red, green, blue, and all, right? So many things we can use. Okay, suppose I am taking the three things. Okay, I am taking width, okay, height, and what I can take, and width, height, and it can be like like if suppose this is a apple. Okay, so what I can do, I can take the height. Okay, it can be width. Okay, or I can take the surface area as well. Okay, it is our surface area, right? So I'm taking the surface area as well. Okay, suppose three entity I am taking. Okay, or weight also I can take, but weight I don't think weight will be good choice, right? So that's why I am taking width, height, and surface area, correct? So apple suppose is having a width of 5 inch or 5 kind of a centimeter, whatever the units never matters. Okay, height is having what? Suppose height is something like 4. Okay, surface area is having suppose 10. Okay, and mango is having width suppose of 4. Okay, height suppose is having 5 or 6. Okay, surface area is 13. Okay, like this, right? So these are what? These are features. I'm just considering an example. Okay, so these are features. I'm having some kind of a system. I'm having some kind of a computer vision technologies through which I can grab the image. Okay, and through the image these things can be calculated. Okay, through which I can grab the image. That is another thing that like grabbing the image and all those parts are of computer vision. So I'm having some computer vision technologies through which I can grab the image, and after grabbing the image, my these things will be calculated. My systems is calculating these things. Okay, so I'm already having these data, correct? Now what I want to train my model. So can we train? No, by using single sample you can't train your model. Okay, you can't train your machine learning model with the help of just single sample, one apple, one mango. We can't do it. We need n number of samples to make a to make a good model, good machine learning model. That means these kind of entity I need, like suppose I'm having 500 samples. Okay, so out of 500 samples, just imagine, just a minute. Okay, just imagine 250 sample is representing apple and 250 sample is representing mango. Okay, so there are 250 vectors. Okay, there are 250 vectors representing apple and there are 250 vectors representing mango. Okay, with different features. Okay, so here apple and mangoes are what? Apple and mangoes are your label. Okay, and these are your features, correct? And we have to make a model that can predict a thing. Like for example, someone is saying he is having a fruit. Okay, he is having a fruit of with 3, height is 4, and surface area is 9. So what is this? Is it apple or is it a mango? Okay, machine needs to tell him that is it an apple or is it a mango, right? So suppose apple is represented by 0 and mango is represented by 1. Okay, so in that case, how a machine will get trained? Machine, to get a machine trained, machine will have n number of algorithms. There are around 20-23 algorithms are there that can be used to make a machine think. Okay, now question how those algorithms work. So we will consider 1 or 2 algorithms and we will try to create a program for those also. Okay, after getting the concept, right? So let's see how those works. Okay, so the thing is, there is an algorithm. There is a very simple algorithm, and that is very popular as well as very, or you can say, successful as well. The algorithm is K neighbors classifier. Okay, or K nearest neighbor. You can call it. Many people call it K nearest neighbors, and many people also call this thing as a K neighbors classifier. It depends. Whatever suits you, you can call it. Both are same. Okay, K neighbors, K nearest neighbor, or K neighbors classifier. What it do? It basically gives the predictions, or machine gives the prediction with the help of knn. Okay, machine gives the prediction with the help of knn by considering the neighbors, by considering the nearest neighbors. Okay, just consider an example. You have to go and watch a movie. Okay, suppose there are two movies. Okay, there are two movies running in your kind of nearest theater or nearest kind of a mall. Okay, there are two movies, movie A, movie B. Okay, now you have to make a choice that you are going to watch movie A or movie B. Then how can you make a choice? There are a lot of ways through which you can make a choice. Okay, so those ways are basically algorithms. Okay, for example, you can watch a trailer. Okay, the trailer you like, you'll go and watch that particular movie. That is what is an algorithm. Okay, that is one of the algorithm. Suppose you just go, you are now, you didn't watch trailer, but you just you are considering the reviews. Okay, you are considering the reviews. Okay, like reviews, movie A got the better review, so you just went and watched movie A. Okay, movie B gets the better review, you just went and watched movie B. Okay, so that is what, that is also algorithm. That means that you are having two algorithms. One, you can watch trailer, the trailer you like most, you will go and watch. The algorithm 2, you will watch the review and then you will go. third algorithms can be what? The third way. Okay, the third way, or I'm giving example like how algorithms work. The third way can be, you are having suppose 5 close friends. Okay, so you will do what? You will ask those close friends, out of 5, 3 said that they are going to watch movie A. Okay, out of 5 friends, 3 of your closest friends said they are going to watch movie A. Okay, and 2 of your friends said no, they are going to watch movie B. So 3 friends said movie A, right? Friends said movie A. So you decide, okay, my 3 closest friends are saying movie A, so I'll also go and watch movie A. So that is how KNN works. Okay, based upon nearest neighbors. Okay, nearest neighbors to whom? To the properties. That means if you have to predict like what can be the output of this 349, or machine needs to predict the output of this 349, machine will start calculating the distance from all these 500 points. Okay, machine will start calculating the distance from all of these 500 points, and it will consider the 5 nearest. Okay, so that one can have a, a majority, 5 or 7 or 9 like this. Okay, so that one can attain a majority. Any one category can get a majority, right? So that's why it will consider the 5 nearest. Out of 5 nearest, three is saying it's apple and 2 is saying it's mango. So it will say this is also apple. Now all discussion is about how it will calculate the distances. Distance calculation, for distance calculating, there are certain ways through which you can calculate the distance. Okay, like like there is one called Manhattan distance. Okay, Manhattan distance, right? But Manhattan distance is not the nearest distance. That means suppose there is a point over here, x and y. Okay, this is a point representing x1 and y1. Okay, this is a point with x2 and y2. Okay, now if you have to calculate the distance, then what I can do, I will use mode of x1 minus x2, okay, plus mode of y1 minus y2. But this is not a nearest distance, isn't it? It is Manhattan distance formula, but this is not a nearest distance, right? Nearest distance is what? Nearest distance is this one. Okay, so how it can be calculated? It can be calculated with the help of Euclidean distance. Okay, this nearest distance can be calculated with the help of Euclidean distance, like this. Okay, now if you have to calculate, what you have to do? You have to use Euclidean distance formula. Okay, that is x1 minus x2 whole square, that is this one, plus y1 minus y2 whole square, this one. Okay, so what will you get? You will get this nearest distance. Okay, that means all these points will calculate its nearest distance from all the existing points. Okay, like it will, the formula will turn like this: underscore 3 minus 5 whole square plus 4 minus 4 whole square, okay, plus 9 minus 10 whole square. Correct? So it is distance 1. The same way, what can be distance 2? Distance 2 can be like this: 3 minus 4 whole square plus 3 minus 6 whole square plus 9 minus 13 whole square, right? So this will continue one after other. Okay, so it will continue from the very beginning to the end. That means continuously distance will keep calculated. Okay, so how many distances will be there? Since we are having 500 samples, there will be 500 distances. Out of those 500 distances, 5 nearest will be considered. Okay, top 5 will be considered, and from those 5, the maximum, or you can say the majority, will be considered to make the predictions about, like, it is a apple, or sorry, not it is, sorry, it is a apple or a mango. Okay, and based upon that, machine will make the predictions and give the predictions. Okay, so this thing is known as k nearest classifier, where k is what? K is 5. Correct? K is a variable, that is 5, right? So that is how your machine works in predicting the k neighbors by using k neighbors classifier. Now the thing is how you can use it, how you can program it. Look, there are so many ways. Okay, if you know how to convert the mathematical intuitions into the program, you are good in programming. Okay, you know about the Python program and all, so you can create a logic like that and can create a program. But if, like, we are new to Python, then all of a sudden it is not suggested that you should go into that particular area where you have to create an algorithm on your own. It is suggested that you should use the libraries that are already there. Okay, it is suggested that use the libraries which are already there, which will do the task on your behalf and will give you the output, or give you the answers, right? Or make a machine train. Okay, make a machine train, right? So that is how we can do it, right? So let me tell how we can use it. For using it, after completing it, I will let you know about the decision tree classifier also. Okay, so quickly complete it and then I will let you know how can we use decision tree classifier. Correct. So to use it, whatever do we have to program? Now where we can program, there are a number of space where we can program. Okay, you can install Anaconda, you can install Python, you can install a number of things. Okay, but here what we are going to do, we are going to use Colab that you might have used earlier also. So you have to type Colab over here, collab.research.google.com. Okay, so what Colab do? Colab basically gives us the, just a minute, give me 1 minute of time. Okay, so Colab gives us the space where you can code. Okay, so you must have used this thing, you know how to use it, file and then new notebook. Correct. So notebook is loading. Notebook is what? Notebook is a IDE where we code. Okay, and once the coding is done, our model is created. We can save our model and we can let the model work. Okay, we can let the model work also. Okay, so what we can do over here, it's like we have to create a classification based model. So we need a data set. So what data set we have? From where we can get the data set? There are n number of kind of resources where you can get a data set. Nowadays getting a data is not a big deal. Okay, because now you're having a very advanced technologies like cloud computing, big data, and so many things are there. Okay, so if we are having this kind of technology, we can use this technology to get the data set and can use the data set. Okay, so getting a data is not a big deal. The if as of now we have to do, we can use some other resources as well. For example, sklearn, sklearn.datasets. Okay, sklearn is what? Is a library or is a kind of a package. Okay, which holds so many libraries. Okay, it's a package that holds n number of libraries. It's a package that holds n number of libraries. For what? For what purpose? Why it holds n number of libraries? It holds n number of libraries for machine learning, for to make a machine learn. Okay, it holds n number of libraries through which you can make a machine learn, right? So you can see over here, these are certain data sets. Okay, so let's consider some classification based data set. Okay, it is written over here, classification, right? So I will consider some of the classification based data set. Let me start with the wine data set. Okay, there are how many classification based data set? There is a iris data, there is a low digit data, there is a wine data, and there is a cancer data, breast cancer data, right? So let me start with the wine data. Okay, so for using wine data, I will click over it and there it is telling how can I use the wine data. It is how I can use the wine data. So I'll just copy this thing, right? And I will paste it over here. Correct. I'm doing nothing from my side, right? Let me give it a name. Day 1 supervised learning classification. I will share the file with you so that you can also access it for your references. Okay, so this is what I did. Okay, so it is how I can access the data. Okay, we can upload the CSV file as well. You must have used CSV file in some previous classes. If not, then nothing to worry. In coming classes, we are going to use some CSV file, Excel file also. Okay, as of now, I am not going to use CSV file. I am going to use the inbuilt data, inbuilt the data that is already there. Okay, now what I will do, I will access this particular data. So when I access the data, it is what I am getting. Okay, it is some kind of random values that you can see. It is not kind of you can't say that what it is written over here. Okay, data is not very much clear. Okay, but one thing that is clear, that data is in the form of dictionary. Wherever this parenthesis present in Python, this parenthesis represents dictionary. Dictionary means what? Dictionary means what? Actually, dictionary is a data type. Okay, dictionary is a data type that holds the value in Python. Dictionary is what? Dictionary is a data type that holds the value of in Python. Okay, by with the reference of keys and value. That means name. Okay, name colon Bipul. Okay, over here it is a dictionary. Okay, which is holding this thing as a name is a key and this is value. Okay, comma age. Okay, so something like 50. Okay, in that case this is what, this is the age, isn't it? So it is value. Okay, and it is what, it is a key. So we are having two things over here. So in dictionary we are having two things, name and age is stored. So these are keys and these are values. So keys are holding the values. Okay, this is how a python, in python dictionary is created, right? So if we are having this particular thing, okay, then it represents what, dictionary. So if it is a dictionary, it must have two things. And what are those two things? Those two things are keys and values. So what I can do, I can call print data dot keys. Okay, so what it will print, it will print the keys. Okay, keys in the data. So how many keys are there? There are 4 keys over here. Okay, as well as I can get the values. But values, getting the values is not a good idea over here, but still I will let you know values. Okay, so these are our values. Okay, so you see the first line is representing key. Okay, and second line, all these things are representing values. So values are very much mixed together. Okay, so that's why I will not call the values like this. Okay, I will only call key. Okay, so I am having what, key over here. Okay, and this key, there are how many keys? 1 2 3 4 5. Okay, so in this key we are having what, this first key is representing actual data. Okay, what data represents, I will let you know. This is representing label in the data, or this is representing feature. Okay, this is representing target name. Okay, target names means what, category, how many categories are there. Okay, and this is representing feature name, like how many features are there. Okay, and it is representing description. It is no, it is of no use actually. Description we are not going to use. We are going to use only 4 entities. So let's see if I will call data over here. So data is what, data is let me use over here df better, df dot keys. To data will be the df of data. So df of data is representing these things. Okay, so df of data is representing what, these many things. Correct. Next we are having what, target, df of target. Df of target is representing what, there are two values it is representing, 0 and 1 and 2 also. Okay, that means there are 3 types of wines. Okay, this is a data of 3 types of wine. Okay, like in environment it was sunny, rainy, and what was that, cloudy. Okay, so there were 3 environmental conditions. So over here there are 3 wine conditions, 0 1 and 2. There are 3 types of wine on which a machine needs to work and make the prediction. What are these? Okay, make a predictions like the category of wine. So how a machine can predict? Machine can predict when these two things combine, the actual features. These are our features, right? These are all features. Okay, these are our features and these are our labels. Okay, so when the features and labels combine, okay, and thereafter machine will give the predictions. Okay, so before we will combine it, let us try to understand more about the feature. So df data, what I will do, there is something called feature names, isn't it? There is something over here, you can see the feature names. So let's call the feature names. Okay, so these are our feature names. Correct. So what feature names are representing? Feature names are representing these things. Okay, alcohol, that means in a particular wine, what are the kind of quantity of alcohol, what is the quantity of alcohol, what is the quantity of malic acid, what is the quantity of alkanicity, magnesium, total phenol, etc. Okay, that means these are the values, okay, which are represented within the data. Okay, so out of these values, okay, these values combined together and representing the class of wine as 0 1 or 2. Okay, that means what? Let's see what I will do. I will use one thing that is known as pandas. You may have used this thing as well. Okay, pandas. It is used for handling the data set in a data frame. Okay, it is used for what? It is used for handling the data set in data frame, right? Then pd dot data frame. Okay, and what I will do, I will put over here df data. Okay, so you will see the data is now in particular columns. How many features are there? 0 1 2 3 4 5 6 7 9 10 11 12. Okay, and how many feature names are there? 1 2 3 4 5 6 7 8 9 10 11 12. That means total 12 feature names are there, and there are total 12 columns. That means each column is representing one feature name. Okay, for better understanding you can also put it like this: columns. Okay, columns is equal to what? The columns name, and these are your columns name. Correct? So these are your what? These are your column names. Okay, so now see the things. Okay, that means for a particular sample, okay, if there is a sample of wine, okay, that wine is representing one of the category of wine. It can be 0 1 or 2. Okay, that wine is having an alcohol level of 14.23, malic acid level of 1.71, ash level of 2.43, and alkalinity like how much alkaline it is 15.6, magnesium 127, and it will represent some kind of a, some kind of a, what that is known as type of wine. So what they represent, what type of wine they are representing, how can we say? Okay, it is not rotating actually. They want to stall it, but it is not getting scrolled. There can be some region over here. Okay, so what we can do then, we can add one more column over here. Okay, I will just update this thing: df wine. Df wine is equal to this thing. Okay, df wine. What I will do, I will just test df wine dot insert. Okay, what I will insert, I will insert location. Location is what? 0. Second column. Okay, column is what? I am going to add a column named types of wine. Okay, and then label. Label is what? Label is given in target, right? 0 1 or 2. df target. You can see over here, these are your df of target, right? So just use it. Correct, and execute it. So you will see df underscore wine. So you can see over here, the first column is representing the type of wine. Okay, and after first column everything is representing the features of wine. Okay, so that we can make a model. Okay, a model using the existing feature, so that we can make a model using the existing feature for predicting the type of wine. Okay, this is what we have to do. Right, we have to make a model, we have to just make a model using the existing feature. Okay, so that type of wine can be predicted. Okay, so let's see how it can be done. Type of wine means what? Like 0 1 or 2, right? Just a minute. Okay, so let's see how it can be done. Okay, for doing it we have to separate these features and labels in two different variables. Okay, so first variable will be what? Types of wine. Okay, so this is your first feature, right? So sorry, first label. Okay, so type of wine will go into y means what? Labels, right? It is what? It is a label. Okay, label is what? Label, or you can say the actual predicted value, right? So y will be what? Y will contain types of wine, so just use it df underscore df bracket types of wine. So df wine, right? It is my df wine, isn't it? Look here, df of wine. Correct, and then I can give over here the string value over here. Correct? It is what your y. Okay. So y is representing what 0, 1 and 2. Okay, these are labels. Okay. Now come to the part x. X will be what? X will be everything. Okay, apart from the types of wine. So what I will do, I just drop it for x. Dot drop. It is saying what? Labels. Okay, I have to pass the label. So what I have to drop? I have to drop this thing, right? So okay, and then axis is equal to 1. Okay, axis equal to 1. Why? Because whenever you have to drop any column, we have to use axis 1, and whenever you have to drop any row, you have to use axis 0. Axis 0 representing the rows, axis 1 representing the column, right? So now you are having two things over here. Okay, one is called feature, second is called label. Okay, in the feature, in the label, only label is considered, and in the feature, everything is considered apart from label. Okay, apart from what? Label, right? So if you call, you can see over here, we are having y representing all the labels in the form of 0, 1 or 2. Okay, and we are having x which is representing all the features. Okay, it is representing all the features. Okay, for any class of wine. Okay, now you have to train your model. How can we train your model? So once the data is prepared, we can train your model with the help of algorithm. Okay, so how can we use algorithm? Let's see. Using algorithm to train your model. Okay, using algorithm to train your model. Okay, this is what we have to do. Okay, so which algorithm I told you? I told you about that. At first I started with knn. Okay, so knn is what? K-neighbors classifier. Correct. So we are going to use K-neighbors classifier algorithm, right? So how can we use K-neighbors classifier? We can use with the help of scikit-learn. Okay, so from sklearn dot neighbors import K-neighbors classifier. Let's see if it is working or not. So it is not working. That means I am doing some mistake over here, right? So let's see. Okay, so I'm doing some mistake. So how can I correct it? I can correct it with the help of scikit-learn. So I just go over here, and over here I will search for knn. Okay, so I'm getting something over here. Scikit-learn. I'm not getting the correct output. So I will just search for K neighbors K-neighbor classifier. Okay, so it is what we have to use, right? So I'll click over it. It will tell me the correct way of using it. Okay, so I have to use this thing. I have to import this part. I'll copy it and I will paste over here. So it's always better to take the thing from the official document, right? Now if I'll execute it, I will not get any error. So why I was getting the error, I might it may possible that I did some spelling mistakes. Okay, thereafter step 2. Okay, step 1, call the algorithm. Step 2, define your model. Okay, step 2 is defining your model. Okay, with the help of algorithms we have to define your model. Correct. With the help of algorithms, what we have to do, we have to define your model. How can we define your model? Just a minute, I will let you know. Okay, just give me 1 minute. Okay, how can we define your model? We can define your model with the help of K. Just give a name to the model. Okay, it can be K model or N model or S model, G model, F model, any model you can do. K model equal to what? Define the algorithm against it. Okay, that is important. And thereafter certain parameter that you have to pass over here. Okay, the first parameter is known as number of neighbors. That means how many number of neighbors you want to consider. Correct? So I will just copy this thing. Okay, and paste it over here. 5. Okay, so it is what done. Okay, number of neighbors. Right, so K model equal to what? K neighbors classifier. Okay, number of neighbors are what? 5. Okay, so first is done, second is also done, right? So step 2 is also done. Step 3, train your model. So how can you train your model? For making a model trained, we have to use a function called dot fit function. Always, whatever the algorithm you are using, that never matters, but at the end, whatever algorithm you use, the inbuilt algorithm, always you have to use dot fit. Okay, whatever the algorithm you use, at the end you have to use dot fit, right? So K model dot fit, what you have to pass? You have to pass X, which is containing feature, and Y, which is containing label. So what fit will do? It will store all the values. Okay, all the values that are present. How many values are present? It is having total X dot shape. You can check over here. Total 178 values are there. That means total 178 samples are there. Okay, with 178 sample and 13 labels are there, right? So with the help of it, I just trained my model. That means I stored the values, total 178 values. Okay, 178 sample. Thereafter, fourth step, make the predictions. Okay, so how can we make the predictions? With the help of inbuilt function named dot predict. Okay, so it can be K model dot predict. Okay, what I can pass? I can pass X comma Y. Sorry, I can pass any values. Okay, any single value I have to pass for the predict, or if I will pass X, then the complete prediction will come out. Okay, the complete prediction is not expected, right? It's like all the values are getting predicted. So what I will do, I will predict for a single value. How can you predict for a single value? I need a single value for that, right? Okay, so let's see. This is my X. Okay, any single value we need. Suppose I have to make a prediction, then obviously I have to take a single value. So what I will do, I will just pick up this particular row. Okay, so how can I pick this particular row? With the help of dot. Okay, iLock. iLock means what? Index lock. Okay, and I will pick up 2. So let's see. So it is showing some error. Just a minute. Okay, so I'm getting what? All the values over here. Okay, for from the location 2. Okay, from the location 2, I'm getting a value like alcohol level, the malic acid level. We have to use these values to make the predictions. Okay, we have to use these values to make the predictions, isn't it? So how can we use these values to make the predictions? We can use these value to make the predictions by using dot predict, right? So what I will do, I'll just copy this thing and will paste it over here. Okay, and x will be replaced by okay. So what it is saying? It is saying expected a two-dimensional array getting one-dimensional array. That means it is expecting a two-dimensional array value, but I am passing only single-dimensional array value. So that's why it is not expecting it. Okay. So let me do one thing to convert this thing into two dimension. If I will pass over here a single bracket open and single bracket close, will it work? Okay, so it's work. So prediction is what? Zero. Zero stands for what? The class zero type of wine. Okay, that means from the location 2, okay, the features are representing class zero. And what is actual level? The actual level also you can pick y of 2. Okay, so it is showing key error because I have to pass over a dot I lock. Okay. So actual level is representing also 0. Okay. Types of wine 0 and predicted level is what? 0. Okay. It is how you can get the predicted level, and it is your actual level that came with along with data. Okay. The actual level was there in the data only. Okay. So you're directly picking from the data. Okay. So the actual level and the predicted level both are same. How the predictions are made? This is having how many points? Total 12 points, because there are total 12 features, right? X I log 2 means what? Total 12 features. If I will call X only, you can see over here how many features are there. These are features, right? So it is total 12 features, 1 2 3 4 5 6, like this. Okay, so with the help of 12 features, okay, the prediction is made, and prediction is giving the type of wine as a 0. Okay, by calculating the distance from all the given points, total 178 given points. By calculating the distance from 178 given points and considering the 5 nearest, okay, 0 is having a upper hand because 0 must be dominating others with maximum number of outcomes. Okay, for this case 0 must be dominating each other with maximum number of outcomes for that particular single case, right? Now it is about the one case. Now what about others? So one by one we can't make the things, like we can't compare. So what we'll do, we'll calculate the accuracy level, correct? And what is accuracy level? Accuracy level is correct predictions, correct prediction divided by total instance or total number of predictions. Okay, so total number of predictions will be divided, total instances will be divided with by the correct prediction. Okay, so correct prediction will be divided. So first of all, figure out the correct prediction. How can we figure out correct prediction? If I will use X dot, or you can say K model dot predict. Okay, I have to predict over X. So these are our predicted value. Okay, these are what? These are the predicted value 0, 1 and 2. This predicted value we can compare with Y. With whom? With Y. Okay, so when you compare with Y, that is your actual value. Okay, you will get either true or false. Okay, but here we are getting nothing. Why are we getting nothing? Because Y is of different data type and predict is of different. Let me check the data type, both of them. Type of Y. It's a pandas data frame, or you can say Y dot data types. It's a pandas data frame basically, and type of this one is what? Okay, so ND array is no attribute called D type. That means it is a numpy array. Okay, the difference is that both of them are basically of different data type. Okay, it is your numpy, right, and it is your what? It is your table, you can say. Okay, or you can say the pandas data frame. Okay, So y is a pandas data frame, okay, and it is of type numpy. Numpy means what? Numerical Python that basically represents the multidimensional matrices. Okay, so multidimensional matrices, right? So the predicted value is represented by data frame or pandas data frame. Okay, the predicted value is represented by pandas data frame. It is represented pandas data frame, and it is what? It is your y is your what? Y is your, sorry, pandas data frame, and x is represented numpy. That means we are having on both the sides. If I have to write over here, on this side we are having pandas data frame, okay, and second side we are having what? Numpy array. Numpy array, right? So it is a numpy array basically. The thing that you can see over here, where is this? Just a minute. If I'll execute it, these are what? These are numpy array, right? Now I have to compare the both the things, the values within y and numpy array with each other. So how can we compare? We have to make sure that both should be in say of same data type. So y dot values. If I put dot values, y will be converted into what? Pandas data, from pandas data frame it will be converted into numpy. Okay, we have to make sure that on both the side the data type should be same. Okay, data type should be same. It is not like that on one side it is pandas data frame, on other side numpy array. On both the side both should be same. Numpy. Okay, on both the side the data type should be same, right? Numpy, numpy, not nampy. Numpy. Okay, so numpy array, numpy array, then only we can compare. That's why how can we convert? We can convert with the help of dot values. Okay, dot values is what? Dot values convert pandas data frame into numpy array. So with the help of dot values, pandas data frame has been converted to numpy array, and then we are getting what? True or false. Okay, true represents 1 and false represents 0. Okay, so 1 plus 1 is what? 2. 2 plus 1 3. If you add 1 for the 5 times, what you will get? 5. If you if you add 1 for 50 times, what will you get? 50. If you add 1 for 100 times, you will get what? 100. Okay, so how many trues are there? Trues are representing the correct predictions. Okay, those predictions where the values, or you can say the actual level and the predicted level, okay, are both are same, right? True is representing what condition? True is representing a condition where actual value which is present in y, okay, and the predictive value that is predicted by k model with the help of distance calculation, okay, both are same and it is representing true. Okay, that means if I have to count it, I can do what? Dot sum. Okay, so we are getting these things 10733, but 10733, is it required? No, it is not required basically. Why? Because it is not the actual size. It is not the actual size. If you can see over here, you can see x dot shape 178. If the number of sample is 178, then how is it possible that the predictions will be 10,733? It is not possible, isn't it? That means we did some mistake over here. So how can we say that what mistake we did? Okay, so let's see check the shape of both of them. Okay, let's check the shape of both of them. After prediction, what shape it is having? Again, the shape should also be same. That is also very important. So after prediction, what is the shape it is having? Dot shape 178. Better. It is having a predictions of 178, right? And what is its shape? Okay. And what is the shape of y dot values? Let's check the shape of y dot values. There must be a change in shape. Print. Okay. It is 178 cross 1. That means both are having different shapes. This is why you are getting a challenge over. That's why you are getting a problem over here. Okay, that's why predictions have become 10733. Okay, both of them should have the same shape, right? Both of them should have what? Should have same shape. Okay, then only it will be good to work with. Okay, so what I will do, I will just change the shape of it. Okay, dot shape, okay, dot reshape. Okay. Dot reshape same as the y dot values. Y dot values is this one, so this should also be the same. Okay, so convert it. So just reshape it. First make the prediction, then reshape it in the shape of actual value, right? And then execute it. So 140. What it's showing, it is showing out of 178 values. Okay, my model get trained with the help of k-neighbors classifier. Okay, and once it gets trained, it is predicting, and now when the prediction came out, okay, total 140 instance the predictions are correct. So what is the accuracy? Accuracy can be divided by total. Okay, it can be divided by total. So total is what? Length of y or length of x. Anything you can give, it depends. It is free. So total accuracy is what? 78%. Okay, that my model is predicting the value with an accuracy of 78% in case of KNA. Correct. If I compare two entity means what? There are two entity over here. That is y. Y is your actual level that actually happened. That is actually representing your types of wine. Okay, like wine is 0 or wine is something 1 or 2. Okay, and second is your what? Second is your this one y dot, this the predicted value, right? So if you are going to watch predicted value is also 0, 1 or 2. Okay, so we have to just compare how many times in both the side, like actual value and the predicted value, both are 0. How many times actual value predicted value both are 1, and how many times predicted value and actual value both are 2. Okay, so when we compare, we got 140. Okay, 140 divided by total, that means total 78% accuracy our model is getting at this moment of time, right? So let me share the code with you, and thereafter I will tell you about the training and testing part as well. But first of all, let me share the code with you. If you're having any doubts at any point, please do ask me. Okay. So I'm putting this link over here. You can access the link, right? If you're having any doubts, you can ask me. Till then, I just want to take a 2 or 3 minutes of break so that I can have a glass of water. And then again, I will join back within the next 2 or 3 minutes. Till then, if you're having any doubts, please do write down in the chat box. I will take your doubts and I will try to answer your questions.
Yes, sir. Yes, sir. Please check sir chat box also, sir.
Yeah, yeah.
Yeah.
Yeah, there are certain questions are there. I will answer it.
Yeah.
Okay.
Yeah.
Okay. So hi everyone. So let's answer. I guess I'm audible, right?
Yes, sir.
Okay. So let's take your queries one by one. Okay, spelling of K neighbors. Okay, fine. Go slow. Unable to follow the commands. Okay, fine. I guess. Do you train model? Okay, train model. Fine. Please send this into attendance link. Is there any way to improve the accuracy? Okay, fine. So I got your things. Okay, so let me tell you everything from the beginning, okay, quickly, so that we can understand the things now. Like we are almost understood, okay, I guess. So 70% of the concept you got, only 30% because in one round everything you can't get like all of a sudden, right? So that's why I said you if you ask, I will answer. Then most things you will get, right? Okay. So I explained first the classification thing, okay, train model and all. Okay, so the first question is what is train model? Okay, so you can see over here, first I accumulated data from certain source. Okay, once I accumulated data from certain source, thereafter we are having the data which is represented by this all things, keys and values I already explained. Okay, and thereafter I converted the data into a data frame. Okay, this is how I converted the data into data frame. In this data frame, the df data is representing what? The data. Okay, so these are your datas, okay, features, and columns is what? Feature names. So these are your feature names representing the column header. Okay, representing the column header. Okay, thereafter I added one more column at location 0. Okay, thereafter I added one more column at location 0, and the column name is what? Types of wine. Okay, column name is types of wine, and df target. Df target are the values that will be stored within this column. Okay, like 000. Okay, these are there already in the data. Okay, thereafter you can see these are there already in the data over here, target, right? Thereafter what you can see over here, we have this data frame created. From this data frame, thereafter I define two variables. The first variable is containing types of wine, that is representing the labels, and second variable the features. Okay, so features and labels, just understood step by step. Okay, so features and labels are separated, x and y. Okay, once it is separated, thereafter we start creating our model. Okay, so for creating a model, the first thing we imported is the algorithm. Okay, the algorithm is what? K neighbors classifier. Okay, second algorithm we have, sorry, we have defined the object of this algorithm with number of neighbors 5, and it is your called train model. Okay, it is something that is called train model, right? That means we define the model. Okay, we define the, what is model? Actually model is nothing, it's just the algorithm. Okay, we just assign an algorithm to a particular variable. Okay, and that variable acts as a model, right? That means we have to just pass certain values to this. Okay, and it will train it. Okay, so my model name is what? K model. So when I put x and y with it, okay, my model get trained. Okay, what trained means in case of knn, what is the meaning of training over here? Okay, the meaning of training over here is it stores the features and corresponding output, features and corresponding output, features and corresponding output. This is only training in case of knn. In case of knn, again I am repeating, it is not in every case. In case of k and n, it stores what? Features and the corresponding output, right? Corresponding output is what? Y. Okay, so that when a new value will enter, okay, like over here you can see a new value. Okay, x dot ilog means index log from location 2. Okay, location 2 I am picking up all the values. So when this new value will enter, it will calculate the distance of this new value from all the existing value that it is having. Okay, that it is having how many values? Existing value 178 values it is having. So whenever a new value enters, whenever user will pass, there's I need a prediction on these features, I need a prediction on these features, right? So what algorithm will do? It will calculate the distance of this new value from all the existing points. Okay, then consider the 5 nearest one, and from that 5 nearest one, the majority will be considered. Okay, so majority is what? Majority is for any particular value over here. For example, if I pass this thing, okay, the majority is what? 0. That means types of wine is 0. Okay, if I change the value over here, the types of wine can change. Suppose I change it to 3. Okay, the prediction is again 0. Suppose I change it to 58. It is still 0. Okay, let me change it to 100. It is 2. Okay, types of wine is what? 2. Correct. So it is for single sample. Excuse me. Okay. For single sample, the prediction at location 100 is what? 2. Actual value is 1. That means over here the prediction is wrong. Okay. So somewhere prediction is right, somewhere prediction is wrong. Right. So if prediction is right, well and good. If wrong, then we have to just check how many times it is wrong. So how can we check how many times it is wrong? We just pick all the values by using y dot values. Okay, y is what your actual value, and we make up predictions. Okay, and we compare these two entities. Okay, this is what actual value that is present with the data, this is what the predicted value. Okay, and then we calculate the sum means what? It will just sum up all the true value represents 1. So when it's summed up and divided by the total value, it is 78% accurate. Okay, that means my model is now 78% accurate. Okay, now there are certain questions over here. Okay, that can we increase the accuracy of the model? Yeah, definitely we do try different ways to increase the accuracy of the model. Okay, we will try those things, like we'll see like how we can increase the accuracy and all. But before that, one more thing we have to understood, and that is known as training and testing accuracy. Okay, training and testing, what it means? It means, just consider a condition where there is a person who is going to write the exam. Correct? There is a person he is going to write the exam. If he is going to write the exam, some questions will be asked to him. Okay. So suppose consider two situations. Situation 1. Okay. I just taught him in the class. In the classroom, I taught him 10 questions. Okay. And their answers. Okay. And then when we went to the exam, I just asked him same 10 questions, okay, that I taught him in the class. In the examination also, I just asking him 10 questions and then expecting an answer from him. Right? In that case, what will happen? In that case, out of 10 questions, he will answer, like he can answer a maximum correct answers. Okay. Maximum correct answers can be given by him. Okay. So that is called training accuracy. That means finding the accuracy on the same data that is used for training, okay, is known as training accuracy. So the 78% that we figured out is known as training accuracy. Okay, but in exam, 10 questions were asked, but these were not the same questions that were asked in the classroom. Sorry, that were taught in the classroom. Okay, these are completely new 10 questions. Yeah, obviously the concept is same. Okay, it is not like that you taught in history and in the examination we are asking the question of math, right? It is not like that. It is like the concept are same, but questions are not same, right? Questions are changed. Okay, so over here in the examination, separate questions are given, okay, to write the answers, and then the accuracy that will come out, that is known as testing accuracy or the validation accuracy. So in real practice or in real world, this accuracy actually defines the capability of a person. Okay, so in case of machine learning also, testing accuracy defines the capability of a machine. Okay, it is not training accuracy. Okay, suppose a machine algorithm, suppose you are using, and that algorithm, instead of training a model, that algorithm just memorizes all the values. May possible, right? It's a mathematics, so it can define some kind of a reference, okay, and it memorizes all the values. So in that case, what happens? The training accuracy will be very high, and on the ground of testing, your model will fail, right? So what is the expectation? Expectation is, if my training accuracy is 80%, the testing accuracy should be close to this 80%. Okay, now question over here, how can we get testing accuracy? For testing accuracy, we need a testing data, but we are having only single set of data, that is X and Y, right? For testing accuracy, we need a separate data, right? So but we are having single set of data, isn't it? So what we can do for that? So let's see what we can do for that. We are having the data set X and Y over here. Okay, X representing your features, right, and Y representing your labels. Okay, so just try to understand the steps that we follow. Okay, So what we do, we divide this X and Y into two different parts. Okay, let me tell you. X will be divided into two parts known as X train, comma, X test. Okay, Y will be divided in two parts known as Y train, comma, Y test. Better? So X and Y will be divided into two parts, that is known as X train, X test, Y train, Y test. Okay, X train can contain maximum portion of your data, for example 80% of your sample size. Okay, then obviously X test will contain 20% of your sample size. So obviously Y train is the corresponding value of X train, so it will be again 80% of your sample size and it will be 20% of your sample size. Okay, so training will be made on X train and Y train. Okay, and accuracy will be calculated on X train and Y train, but that will be your training accuracy. Okay, but on X test and Y test no training has been made, but accuracy will be calculated and that is your testing accuracy. Okay, let's see, apply, thereafter we will configure, we'll figure out the concept out of it, right? So what we have to do, we have to divide the data into two parts. So how can we divide? We can divide the data with the help of train, test, split. Okay, what is train, test, split? Train, test, split splits the data into two parts, correct? So from sklearn dot model selection, import train, test, split, right? And then it's inbuilt library, and then xtrain, xtest, or basically I have to write over here train test split x comma y, right? So x comma y written, x will be divided into two parts, right? So xtrain comma xtest, and y will be divided into two parts, y train comma y test, right? These are the return values from the few library that we are using. Okay, the library that we are using, these will return four values. Okay, so you can see over here x dot save, how many values? 178. xtrain dot save, it must be around 75% of total. Okay, it is what, 75% of total, 75% of 178. Okay, I want little more. Okay, so what I can do, I can define over here train underscore size is equal to 0.8. Okay, train size 0.8, that I want in training set, I want little more, so 80%, 142, total 178. Okay, in testing set 36. Better? Next, we have to train our model. Okay, now we'll figure two things, not just training accuracy, now we have to figure out testing accuracy also. So how can we train our model? Obviously algorithm. So algorithm come out from where? From sklearn, from sklearn dot neighbors, neighbors import k neighbors classifier, k model is equal to k neighbors classifier. Okay, and thereafter train your model. How to train? Obviously I told you k model dot fit, always the parameter will change now. Okay, earlier it was x and y, now it is x and y train. So model get trained. Okay, so once it is trained with a number of neighbors equal to 5 and all, okay, it got trained. Thereafter what we can do, we can figure out the accuracy. For figuring out the accuracy, first of all we have to predict, right? So first make a prediction over training data, prediction over training data. Second, make a prediction over testing data, prediction over testing data. How to make a prediction over training data? Very simple, just use over here, just a minute, wait 1 minute, k model dot predict, okay, x train. So when you make a predictions over training data, this will be your predictions over training data, correct? Okay, and you can compare this thing with y train. Okay, so when you compare this thing with Y10, you will get something like this. Okay, not getting compared because the problem of shapes and all, isn't it? Because shapes are not, we have not adjusted the shape like we adjusted earlier, right? So first of all, we have to check the shape of both of them so that they can be adjusted, right? So just check the shape of this one and check the shape of this one. Both should be in same shape. Okay, print it and print this thing also. So 142, 142, that means the first value is in single dimension and the next one is in two dimension. Obviously, they can't be compared together. Both should be in, if both are single dimension, that's okay. Or if both are in two dimension, that's okay. It is not possible that one is in single dimension, one is two dimension, that will not work. So just use over the dot reshape. Okay, change the shape of it to 142 cross 1. Okay, this is how we can change the shape of it, right? So now when it is changed, thereafter we can compare. Okay, thereafter what we can do, we can compare like this, double equals, and this shape will be removed. This is already 142 cross 1, isn't it? Now if you compare, we are getting true or false. We have to count how many trues are there. We can just put over a dot sum. Okay, dot sum and divided by total value, that is length of x string. Okay, length of what? Length of x string. Now if I will print it, I will get the accuracy for training data. Print, it is what? It is accuracy for training data. Better, 83% accuracy over training data. Correct? Now make the predictions over testing data. For testing data, same model will be used. No new model will come all over. Okay, K model that is used to train on X and Y and same model will be used. K model dot predict X test. So when you make the predictions over testing data, you will get again 0, 1, 2, something like this. Okay, and there is an actual value also, that is Y test, isn't it? Y test. This is your actual value. Okay, compare both of them, but shape should be same, isn't it? So check the shape of it dot shape. Okay, 36 cross 1, make it also 36 cross 1. Okay, now compare both of them, double equals, remove this shape from here. Okay, when you compare, you will get true or false. Okay, and then what we can do, we can just use over here dot sum, okay, divided by length of x test divided by total. Okay, so accuracy over here will be what? Okay, so accuracy over here is 66%. Okay, so when we are having this kind of situation, what we can say, that there is a huge difference between training and testing accuracy. Okay, so what we try to decrease this kind of situations. If training accuracy is 83%, the testing accuracy should also be around 80% or something like this. Okay, it should not be like, it should not be a situation where the training and testing accuracy will have a different kinds of you can say the difference is quite huge. Okay, so let me try one more time the training. Okay, so what I will do again, I will split it with 75% in training. Okay. So now X train will have how, what size? It is 45. X train is having a size of 133, right? So I will make it 133 with 45. Okay. 78, 75. So this is a better situation. Okay, this is a better situation where the accuracies are close to each other. Okay, it is 78 and 75%. Okay, in the early cases, in the first case, what happened? The differences was too much. So that model, that kind of model, basically is not. We are not going to use that kind of model where there is a huge difference between training and testing accuracy. Okay, now how it gets better? It gets better because the number of data in testing increases. Okay, so is it the only way to get the things better? No, there are n number of ways, and that is called data pre-processing. Okay, there are n number of ways through which we increase the accuracy or do these things. Correct. One of that is known as parameter tuning. Okay, one of that is known as parameter tuning. So what is a parameter over here? Here the parameter is parameter tuning. Okay, so here the parameter is what? Here the parameter is value of k. For every algorithm, the parameter is different. Okay, the parameter which basically controls or on which the the complete learning depends. Okay, here the value of k is the parameter. Value on the basis of k, the model is getting trained. Right. So here the value of k is what is basically a parameter. Okay, so that is what we can tune. As of now, we are using one. So what will be the better parameter to use? Okay, how can we figure out what is a better parameter to use? Okay, so we can figure out with the help of a particular visualization. Okay, graphical visualization. That means we'll change the value of k continuously. For example, for I in range 1 to 15. Okay, if I will use it, and value of k over here, if I'm using I, that means what? That means I am in this loop, the value of k, or you can say the value of the what this is known as the value of number of neighbors. Okay, the number of neighbors are continuously changing. Okay, first it is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so number of neighbors changed from 1 to 15. Okay, so that's a huge change. Continuously it is changing, right? That means what we can use over here, we can use k model is equal to k neighbors classifier. Okay, and within the bracket we can pass number of neighbors, right? So let's just copy and paste. This is a parameter, right? Number of neighbors equal to not 5. Now it is not just 5, it will change continuously. First it will be 1, then 2, then 3, then 4, then 5, 6, 7, 8, 9, 10, and 12, 13, and 14. Right? So 50 number of neighbors will be used. Okay. Train the model for 15 different times. K model dot fit x train, y train. Okay. And thereafter calculate the accuracy for 15 different times. So this is accuracy. This is a training accuracy. Correct. So use it. Okay, so it is what? Training accuracy, TR underscore AC. See, this is your training accuracy. Okay, this is your training accuracy, right? For 15 different times it will be calculated, and this is your testing accuracy. It will also be calculated for how many times? For 15 different times. Better. So training and testing both accuracy are getting calculated for 15 different times. Okay, that means 15 values of training and testing accuracy. Define a array training underscore accuracy is equal to null array. Okay, and define one more array testing underscore accuracy is equal to null array. Better. Okay, then what we can do, we can put this training and testing accuracy in those array. How can we put? We can put with the help of a function named append. Append means what? Keep adding one after other, create a chain. Okay, create a chain, that is called append, right? So training accuracy dot append, which is by default is having no value. After first loop, the first accuracy of training will be appended, right? And testing accuracy dot append, after the first loop, the testing accuracy will also be appended. First loop, then second loop, then third loop, then fourth loop, then fifth loop, like this, right? So it will get appended, right? And then we will execute it. So once we execute, what we will get? We will get two array or two list. You can see over here. One is your training accuracy, training underscore accuracy. Just a minute, let me check it. Okay, capital T is there. So we are having what? Training accuracy. Okay. It is having a value like this. Okay, training accuracy, you can see a value 87, 88, some accuracy with that we are getting, right? And second array we are having is testing accuracy. So comparing these two things visually by just looking at the figure is not okay, isn't it? Testing accuracy. Okay, there should be some way that is called data visualization. So what we will do, we will use a data visualization technique through matplotlib. So we will import a library called matplotlib dot pyplot as plt. Okay, this is a matplotlib library that this is used for plotting plotting the value on x and y coordinate. Okay, what I mean, plt dot plot. Okay, suppose x coordinate is 5 7 3, y coordinate is 3 7 9. Okay, and then plt dot show. Okay, so it is a plot, right? So what we will do, we will give x coordinate as range 1 to 15 for 15 times, because the training has been done for 15 times, and y coordinate as training accuracy, right? I'll copy it and I will paste it. Better. So this is a plot of training accuracy. It is showing like how the accuracy changes. Okay, like where it was higher, where it was like lower. Like at some point it was just like 100%. Okay, and over here it is 70%. Right, so accuracy changes with the different value of k. It is changing. So it is giving us idea that using a number of neighbors equal to 1 is the best choice. Shall we use number of neighbors equal to 1? No. We can decide only after comparing this plot with testing accuracy. So we'll plot it again on the same plot, testing accuracy. So when we plot it, this is what we are getting. That means if we will use number of neighbors equal to 1, okay, then training accuracy is very high, that is 100%. That means on the known data, my model performed quite well, but on unknown data, the accuracy level is around 77%. So that is not a good model. That is not a trustworthy model. That means on that model, no one can trust, right? So we need, the accuracy can be lower. Suppose if the accuracy is lower, it is the accuracy is 80%, but if you can trust, okay, and someone is saying that his model will give 100%, but he is saying no, like my model can give 100%, but sometimes it also gives 70%. Okay, so we can't trust it because 70%, sometimes it is giving 70%, sometimes 100%. We can't trust it more. Okay, at the same point of time that someone is saying no, my model anyhow will give a range of accuracy between 80 to 82%. Okay, either 82% or 80%, this will be the accuracy range, so we can trust on that model more. Correct. Same thing over here. So what we figure out, if the accuracy, if the number of neighbors is 5, okay, if the number of neighbor is 5 on the data that is given, accuracy is little low, but on that model we can trust because the training and testing accuracy is very close. Okay, for number of neighbors 9 also it is close, so number of neighbors 9 also can be used. Okay, but again using a number of neighbors 9 or any other, okay, any other, if you are using, you may think like it is crossing over here, but it is not crossing, it is not an intersection over here. Actually the point is 11, and on 11 it is like this. Okay, if you have to compare, you can compare it like this also. Apart from plot, I can also use scatter. Okay, so this is scatter, but it is not. So in just a minute. Much better, right? So you can see the exact points. So 5 is the best situation or 9 is the best situation. Okay, 5 or 9 that we can use, that is showing a best possible close value between training and testing accuracy, right? So it is how we tune the parameter. Number of ways of tuning the parameter, right? The number of different parameters are there, parameters, hyperparameters are there that we tune to get a better possible condition of best possible accuracy. Okay. Next, what are the other ways through which we can increase the accuracy, right? There are, that is known as data pre-processing. Okay, that means what? If you get the data over here X, okay, so in this X value, okay, the values are given over here, some values that are given over here, right? So what we can do, we can remove the outliers and all from this value. We can remove the outliers, we can remove a lot of things from here. Okay, for example, let's consider a case X alcohol. Okay, dot minimum. Okay, because data also contains some values that are not expected, right? Or some wrong value may contain. Because of that, also accuracy decreases. So I will tell you about the data pre-processing in upcoming classes. As of now, I'm just giving you the idea of why data pre-processing is required to make a model. Oh, minimum, maximum. Data pre-processing is a very kind of a minimum mean value. It is one of the job that, you know, that of particular if there is a person, if there is a machine learning developer, so machine learning developer used to give 70 to 80% of the time on data pre-processing, just because he needs to create a data, he needs to figure out the kind of data which can give the maximum accuracy. Okay, so one aspect of data pre-processing I am telling you, this is called outliers detection or outliers removal. Okay, so you can see over here the minimum value of alcohol is 18, maximum is 14, and average is 13. Okay, so it shows minimum and maximum is close to, you know, is very close to this mean value. Okay, so we can say that there is no such outliers in case of alcohol. Okay, and the columns. No such outliers in case of alcohol. That means the values are in a range only. Okay, same way we basically what we do, we check for others as well. Okay, for everyone. Okay, for everyone, for all of these values. Okay, we check. Okay, so over here we can say there can be a lot of outliers. What it is saying, the minimum value is 0.74. Okay, maximum is 5.8 and average is 2.33. Okay, that means the minimum value is very lower than the average value. Okay, and better, we what we can do, we can do like this: x malic acid dot describe. Okay, so what it is saying, total count 178, mean value is 232.33, that is the average, standard deviation 1.11, minimum is 0.74, maximum 5.80, right? So it is saying what, that there can be some outliers over here. Okay, so here we can use the standard, we can use the standard deviations, okay, to define, to take a range of malic acid. Okay, that means the extreme conditions needs to be removed. Okay, extreme condition means what? Just a minute, I will explain it in a better way. I'm searching for the pen. Okay, so it's like, just consider a case. where you are having what? Mm, okay, you are having this thing. Okay, you are having, suppose, the values like this. Okay, these are your values, right? These are your values, right? All the values are over here. Okay, these are your values representing. Okay, and there are certain values that are present over here, and there are certain values that are present over here. Over here. Okay, so because of these three values, which are at extreme conditions, extreme outwards or extreme inwards, okay, your accuracy will be affected. Your accuracy can be affected a lot because these are not representing major part of your data, because major part of your data is basically over here only. Okay, so that means it should be considered more. It should be considered more. But since the value of these things, okay, it is having a very high value. Suppose these all are in a range of, suppose these all are in a range of 5 to 9. Okay, and this is having a value, suppose 20. So obviously this single value, the single outlier, which is having a very high value, since it is having a very high weight also, 20 as compared to this one, so this can affect your model a lot. Okay, it is just one in number. Okay, it is not like too many, it is just one in number. Okay, but still the value is quite high, that's why it can affect the same extreme inward. Okay, so these extreme conditions are known as outliers in the data, right? So what we do, we try to figure out the outliers, okay, with the help of standard deviations and all, and try to remove it. Okay, because once the outliers will be removed, thereafter the data, that is called data cleaning. Okay, thereafter the data with the less number of outliers can help us a lot. Okay, can help us a lot. Okay, let us plot it. Just see plt dot scatter. Okay, range 0 to length of, okay, I'm just finding like, okay, this one x, how many brackets I have to leave. Okay, after this I can write, right? Okay, and then I will give over here x of malic acid, right? Let me check. Okay, so you can see over here. Okay, so maximum values, right? You can see that is what I'm trying to explain. Okay, so maximum values are basically in this range, right? This is the range. Okay, but these are the outliers. These are extreme outliers. Okay, these are extreme outliers, right? So that means these needs to be removed. So how we can remove? We can define a kind of a, you can define a some kind of a what that is known as, we can define a threshold value. Okay, we can define a threshold value that all the malic acid values which are above a particular threshold, that above 4, okay, will be removed. Okay, so all those values which are above 4 will be removed. Okay, so that your data can be more relevant and more controlled. Okay, it can be more relevant and more controlled. So that is called data cleaning or data pre-processing. Okay, so these are the steps basically we apply for, for kind of this thing, so for making your model more better. You can see, I will show you for other one also. If I will consider alcohol, then let me check for alcohol the outliers are there or not. I will tell you this thing in detail also. Like generally we use standard deviation for it. Okay, but for that I have to explain standard deviation first. So when I will explain standard deviation, then I can let you know like how we can do it. Uh, okay. So in case of alcohol, it is not such outlier, you can say. There is no such outlier because all are kind of in a relevant positions. Okay, very close to each other. If any value suppose present over here, okay, if any value suppose present over here, if any value suppose present over here, so these are known as outliers. Okay, if any value present over here means out of the group actually. Okay, but most of the values are actually within the group, so a model can easily figure out, okay, any algorithmic formula or any mathematical formula can easily figure out the pattern. Okay, and based upon that pattern the predictions can be made. Okay, so for alcohol there is no such outliers, but malic acid can affect a lot. Okay, The same way there are total 14 values. Okay, so what we do, it is very necessary that we can figure out the outliers for each of them. Yeah, each of them, I'm saying it's like each of them needs to be figured. That's why I said that for a machine learning developer, it's like most of the time, almost 70 to 75% of the time is spent in just working with the data. Okay, and thereafter the algorithm came, and thereafter things are basically done. So in this case, you can see there are outliers over here. Okay, it is what? It is a outlier. Okay, so we can say that all the values above 25 can be removed. Okay, because these are the outliers. Okay, because most of the values are present over here, they can affect a lot, right? So that is how things basically, that is how we could treat it. Now just ask your query. Okay, I'm giving you time. Okay, I have already shared the code with you. Okay, there are lot many things are about to come. Okay, like we'll discuss regression, we'll discuss the data pre-processing and all. Okay, in the upcoming classes, right? Till then, just go with the part that I discussed today. Okay, and if you got any query after the class, that also you can note down. As of now, if you want to ask anything, just ask. I am going to take your chat now. Okay. How to know that? Okay, one by one. Okay, how to know that predictions are wrong? I guess I answered. You got the answer? How to know that predictions are wrong? By comparing with real value, right? Yeah, by comparing with real value, or if suppose you are making a prediction for a case which is unknown, if you're making a prediction for a case which is unknown, obviously in that case you can't say that prediction is right or wrong until or unless the situation actually happens. In case we encounter that our model is not predicting right, how to do problem spotting? Like you want to ask, like how can we come to know that okay it is not predicting right? How to do? Yeah, by calculating the accuracy and all. By calculating the accuracy, you can figure out that your model is, predicting well or not predicting well. Yeah, I'll share the code. I'll share the code. Thanks a lot, sir. So go through it. I'll consider certain more interesting use cases in upcoming sessions, and we'll try to figure out these things more dynamic way.
Yes, sir. Because, sir, like it is very confusing by seeing this. I mean, graphical visualization and from the table, like in alcohol, you have shown. So
Hmm.
can you just scroll above the alcohol one?
This one, this one.
All data. Yeah, minimum, maximum standard deviation value. Yeah, yes.
This one. Yeah.
Sir,
Hmm.
alcohol one, first alcohol one, not malic acid.
Just with alcohol. I just
Yeah,
actually
yeah, sir, here only.
uh,
Uh,
the graphical you want.
no, sir, not graphical. That
Okay.
standard deviation, min, max
Actually,
value one.
got it.
Okay.
Actually, I just replaced this thing with malic
Sir,
acid.
it's okay. Sir, for an example, sir, just take for the malic acid. So, okay. Min max one, the malic acid. Sir, like the 25%, 75%, and 100% values, they were lying between the 0.8 and 5.8 only. And like in graphical visualization, you have shown the outlier. But according to this data, I mean, the 25%, 50%, and this 75%, all the values are between min and max. So we cannot judge like here lies any outlier. And like you have shown in the alcohol data one, all the values were between min and max.
I got your.
Yeah,
I
but I
got your
think you
query.
will be covering this in the upcoming
Right,
classes, right? Yeah.
I got your query. The thing is, obviously, the all the values will be in minimum and maximum only. Like, if how any value can be outside minimum and maximum, right?
Uh,
So,
yes सर अल्कोहल में भी एवरी वैल्यू लाइक 25 50 एंड 75% के बीच में तो
definitely,
जो थी वो सारी उसी में आ रही थी मिन मैक्स में तो आपने बोला
definitely,
कि वहां पर तो नहीं आउटलायर और यहाँ पर भी जो मुझे दिखाई दे रहा है सारी मिन और मैक्स के बीच में ही आ रही हैं 25%
definitely.
50% बट
मैं
स्टिल
बता रहा
देयर
हूँ.
आर आउटलायर्स सो
मैं बता रहा हूँ देखिए like for outliers how we judge outliers generally, right? It is, if there is a value, any value you are considering, any particular feature you are considering, okay, like 0.5 suppose minimum, 0 point and suppose 10 is the maximum, so obviously all the values will be in between, Okay, it is not possible that any value is outside the minimum or outside maximum. That is not possible, right? All the values, whatever condition you consider, it will be always between minimum and maximum, right?
So then outside that values,
Let
that will be considered as outlier, right?
so so if there is a value outside minimum, then that will be the new minimum, right? Getting my point? That will be the new minimum, right? So let me complete. You'll got the answer. Okay, so suppose it is a minimum and it is a maximum. We don't go for the minimum maximum. Okay, we have to figure out the range in which all the values are lying. Okay, that is basically defined with the help of standard deviation. Okay, you know, simple mathematical things are almost 70% of the values lies within first standard deviation. Okay, first standard deviation. Okay, rest you can say 70 after 70%, around 90% of the values lies in between second standard deviation. Okay, this is your second standard deviation. Okay, that means what you do, we have to just make sure that our maximum, we have to just make sure that we are going to use first standard deviation or the second standard deviation or the third, because if we are going to consider this thing, I'll go into this thing into detail. Okay, I'll go into detail, don't worry. And then we decide the bar, this bar we have to decide. Okay, not minimum and maximum. Okay, that means we are going to consider which bar. Okay, so that maximum relative information we can consider. Okay, so that
Sir, everything is clear. Only that part is not clear. I think you will be covering this
right,
like in
right, right,
the,
right, right,
yeah.
right. I will explain in detail.
Otherwise, all the part is like crystal clear. Only this part, like how we are. I mean, the K part is clear. How we are deciding the. I mean, the K value. But this part is like a bit complex.
Got it, got it, got it. Nothing to worry. I will go in much detail into it. As I said, I'm just giving you a simple kind of the insight, like why data pre-processing is important, right? Because the thing, like in this case, you can see that the where the data's, the outputs or it's the data points are at the very extreme, not minimum maximum. At very there are certain points. They are very limited. There are 1 or 2 points are there, or 5 points are there. Okay, which are at very, very extreme. Okay, so those extreme needs we have to figure out and we have to remove, right? So I'll come into the detail of it, don't worry. Okay,
Thank you, sir. Thank you.
yeah, thanks a lot. How to come to know where we got wrong? Okay, when you compare the, or not, no, the predictions, when you compare the predictions, for example, just a minute, if you say white train, what is white train? White train is actually your actual label of what? X train. That means the first sample is representing 2, second sample is representing 0. Correct. And if you write over here K model dot predict, okay, K model dot predict what? X train. So it is what? Same sample predictions. Same sample predictions. Okay. These are actual existence. These are the predicted existence. Okay. So when you compare these two values, then we come to know that where we are correct and where we are wrong. Okay, because when we compare these two values, we will get what? True or false. Okay, so the point where we are getting true, that means our prediction are correct at that point. Okay, and the point where we are getting false, that means at those points where our predictions are wrong. Okay, getting my point? Like if you compare these two things, double equals. Okay, if you compare, okay, let me write it in a separate line. White train double equals, compare the actual value with the predicted value. These are the predicted value of X train. Correct. So when you compare it, at some point it will be true, at some point it is false. Okay, but both shapes should be same. But again, I don't know the shape. I guess just a minute. White train. So let's see. Okay, 133 cross 1 better, and the shape of this one should be also same. Like it's 133, so we have to just reshape it. 133 cross 1. So when you compare it, what are you getting? We're getting this true or false, correct? So we can easily figure out like where its predictions are correct, where the predictions are wrong. Am I clear now? If it is false, that means at location 4, the prediction is wrong. Mr. Pratik? Yeah. Okay. So it was the main class of supervised learning classification. Okay. In future, we'll see some more things about regression, about data pre-processing, unsupervised learning. Okay. Or you can say the deployment of a model also. Okay. How can you save a model? How you can deploy a model? Right. Those things also we'll see. Let's see in the upcoming classes. That's it for today. So if there is no further question, can we sign up?
Yes, sir. No question.
Okay. Okay, sir, are you there?
Yes.
Okay. Can we sign off then?
Yes. I think no one is curious then.
Okay.
Okay. Yeah.
Okay, sir.
Okay, then now can we end session? Okay.
Okay.
Yeah.
Thanks. Thanks a lot, sir.
Yeah. Thank you very much. Thank you very much, Bipul. And thank you very much all the participants having patience learning. Okay. So we will meet tomorrow sharp 10:20. Okay.
Right, sir.
Right. Okay then. See you.